Hello student, in this video we will study about the reflection of light. So what is reflection of light? When the incident ray passes obliquely from one medium to another medium, the bending of light takes place. This phenomenon is called as refraction of light. So here few things we will first understand. If we have a transparent surface, why we are using a transparent surface? Because refraction is only possible when the light will move from one medium to another medium. Transparent medium is basically the interface between the medium. If on the top side we take air and in the bottom side we take the glass. So air is one of the medium. Let us assume this is medium 1 and glass is medium 2. So if any incident ray that moves from medium 1 to the medium 2, this is the incident ray, it touches the interface, it will bend. As you see here, what happened actually, if there is no medium 2 present, this incident ray could pass through this way, but because of change of the medium, the incident ray gets refracted, and due to that bending of light takes place. Now this ray is called as refracted ray, and this is a normal. Normal, we know normal is the ray that is perpendicular to the surface, and it is the imaginary ray. So here the angle that you notice, this is called as angle of incidence, and this is the angle R, so it is called as angle of refraction. So how you can identify that medium is changing? So medium is changing when bending of light takes place. So here this air is medium 1 and the glass is medium 2. It means that the speed of light in medium 1 will not be equal to the speed of light in medium 2. It means that mediums are separated due to change in the speed of light. Medium is identified due to change in speed of light. Let's take example, air. In air, the speed of light is approximately 3 into 10 to the power 8 meter per second. And in glass, the speed of light is approximately 2 into 10 to the power 8 meter per second. So what happened? If we have a surface and this is the incident ray, here we can make a normal and it bends towards the normal. So air speed is 3 into 10 to the power 8 meter per second, and glass speed is 2 into 10 to the power 8 meter per second. So speed of light in air is more than the speed of light in glass. So air is considered as a rarer medium and glass is considered as a denser medium. So one thing always remember, rarer and denser could change according to the medium to medium. It's not fixed identity. Here glass is a denser medium, but when we use a diamond, then it will become a rarer medium. So what I try to say, if we use the air as one medium and glass as the second medium, so air is considered as a rarer medium. Why? Because its speed of light is more and glass has denser medium. But in the second condition, when we are taking diamond and second we are taking a glass, so in this case diamond becomes the denser medium and glass becomes the rarer medium. So this rarer and denser medium changes when we change the medium. I hope you understood this point clearly. Next is when the incident ray passes from rarer to the denser medium, the bending of light takes place towards the normal. It means that if we have a refracting surface and this is the incident ray and here is the normal, so the incident ray will bend towards the normal. Towards the normal means if there is no transparent medium, then light will pass in this way. But because of the medium, and this medium is a denser medium, so what will happen? Light will move towards the normal. Similarly, if we take denser to rarer medium, when the incident ray moves from denser to rarer medium, it will bend away from the normal. Refracting surface, this is the incident ray and here is the normal. So what will happen? Incident ray will move away from the normal. So in this case, what will happen? Refracted ray will move away from the normal. So it will go away. If there is no transparent medium, then it has to move in this direction. But because of denser to rarer medium, it will move away from the normal. I hope you understood this part. So in short, I just write it down. Sometimes MCQ question comes based on this relation about the obliquely. Obliquely means not perpendicular. In simple way, we can say that incident ray must be greater than 0 degree but less than 90 degree. Then we say that incident ray is oblique in nature. So what will happen if incident ray is oblique, and what will happen if the incident ray is not oblique in nature? Both the conditions we will see. So first, let's see when incident ray is perpendicular. Perpendicular means not oblique. So here I am taking a surface, and this, suppose this is our incident ray. So I try to make the two end of the incident ray. This is the one of the end and this is another end. It means that this incident ray, we try to make it wider for better understanding. So it will look like. So as you noticed on the surface, this is suppose your incident ray left side. This is the incident ray right side. Both are the single incident ray, but for better understanding, I just try to make it more wider. So you notice it here, both the left and right touching the surface together. So what happened if we are using a medium air and down we are using a medium glass? We know that air is a rarer medium and glass is a denser medium. So what happened? Both the left and right will change the speed of light together. It means that if the speed of light air is 3 into 10 to the power 8 meter per second, so both the left and right will move with the same speed even when they are touching the surface. And after touching the surface, what will happen? They will move with the speed of light in glass, that is 2 into 10 to the power 8 meter per second. So what will happen? Both will move together with the same speed. So what you noticed in this case, no bending of light takes place. So we can say that when angle I is equal to 0 degree, means angle of incidence is equal to 0 degree, or you can say that when angle I is perpendicular to the surface, then no bending of light takes place. So the same thing we can also draw. This is the surface and this is the incident ray. So incident ray is perpendicular, so it will pass the surface without bending. So this is our case number 1, where incident ray is perpendicular to the surface. Second condition we take, where incident ray is not perpendicular to the surface. It means incident ray is oblique in nature. This is our refracting surface, and here one of the incident ray, I'm trying to expand it. Okay, so that's why I'm considering one side as left and another side as right. So here this is our a single incident ray, but in a wider view. So this is our left side and this is the right side. Both are parallel to each other. So here you might think that left one is more in length than the right one, but actually it's not like that. If I try to merge these two rays, both are same in the length. So that's why here, if the left side of incident ray touches the surface, let us assume at A, that time right one is in the rarer medium. I just write it down. When A will reach the surface, That time A want to move with the speed of the glass, which is 2 into 10 to the power 8. But B is in the same medium. So B want to move with the speed of 3 into 10 to the power 8. So because of this change in the speed on the surface, bending of light takes place. And when the both left and right incident rays passes the surface, then again they will follow the same path. Refracted ray will bend here. It means that if this is the surface, this is the incident ray, but because of the change of the speed of the light for both the left and right rays, bending takes place. And when the bending takes place, then both the rays will move with the same speed. I hope you understood this part completely. Now our next topic is refraction in the glass slab. Glass slab is a cuboidal transparent solid. This is a glass slab where all the surfaces are rectangular. So if we see the refraction in the glass slab from this surface, and here is our incident ray. This is the incident ray. So the incident ray look like, here is the normal. So we just studied that when the light ray passes from rarer to denser, it always moves towards the normal. This is our air, which is a rarer medium, and here is our glass, which is a denser medium. So what will happen? Incident ray will bend towards the normal. And again, this is one of our refracting surface AB. Then there is another refracting surface CD. But in this case, if we make a normal, so what will happen? This is the incident ray. This is the refracted ray. Now again, refracted ray comes to the surface CD. So again bending of light takes place because now the refracted ray moves from denser to the rarer medium. So what will happen? It will move away from the normal. So suppose if there is no glass slab, so what could happen? In that case, this incident ray could pass through like this. So the angle that is formed here is called as angle of emergence, and the ray that is coming out is called as emergent ray. If we make a perpendicular line between the emergent ray and the extended incident ray, this distance is called as lateral displacement. So how we can define lateral displacement? It is the shortest distance between the emergent ray and the extended incident ray. Shortest distance means displacement, and displacement is always possible when we draw a perpendicular over it. So I hope that you understood this part completely. So till now we got idea about the refraction of light and how the refraction of light behaves in the glass slab. Now we will move to the laws of refraction. There are two laws of refraction. First is the ratio of sine of angle of incidence, which is represented as angle I, to the sine of angle of refraction is constant. It means that sine I by sine R is equal to constant. This constant is called as refractive index, and it is represented as n or mu. I will explain about the refractive index shortly after the law of reflection. So second law is the incident ray, the refracted ray, and the normal all lies on the same plane. If this is the surface, here is the incident ray, this is normal, and this is refracted ray. So if incident ray is in the xy plane, normal will become xy plane, and refracted ray will also present in the xy plane. So all the three, incident ray, refracted ray, and the normal, lies on the same plane. Now we will understand about the refractive index. So here, first we understand about the optical density. The optical density is a property of a transparent material that measures the speed of light throughout the material. So what is the meaning of optical density and how it is different from mass density? So first thing I want to say it here, mass density is a different property. It means that mass density is not equal to optical density. So here, for measuring the mass density, we need mass and volume. But for measuring the optical density, we need a refractive index. Means we know that density, mass density is equal to mass by volume. Here, optical density is directly proportional to the refractive index. It means that we can measure optical density with the value of the refractive index. More the refractive index, more optically denser the medium is. More the refractive index, more the optically denser the medium. So if we need to define refractive index, we can say that refractive index measure of the bending of a ray of light when passing from one medium to another. So when bending is more, it means refractive index is more. More the bending of light, more the refractive index. So in the laws of refraction, first law was, so in the first law of refraction, that was sin I by sin R is equal to constant. It can be written as n21. And what is n21? N21 is the refractive index of medium 2 with respect to medium 1. It means that if we are taking refractive index of water with respect to air, it has different value. Suppose it is A. Similarly, refractive index of water with respect to glass, it will have different value. It means that if we have a water as one of the medium and another medium is air, here if we have one medium is water, another medium is glass. So what will happen if any incident ray passes from air to water? Bending will change. Even the water is same for both the cases, but bending will varies. So that's why refractive index will change because mediums are changing. So refractive index is not a fixed value for a specific medium. If other medium is changing means refractive index will also change. I hope you understood this part completely. Let's see some formulas that we are using to solve the refractive index based questions. So other definitions of refractive index. Refractive index of a medium is defined as the speed of light in another medium to the speed of light in the same medium. So we can say that N21 is equal to V1 by V2. It means that refractive index of medium 2 with respect to 1 is equal to speed of light in medium 1 to a speed of light in medium 2. So let's take an example. If the speed of light for air is 3 into 10 to the power 8 meter per second and the speed of light of glass is 2 into 10 to the power 8 meter per second. So how to find the refractive index of glass with respect to air? So we can use the formula N glass air is equal to speed of light in air by speed of light in glass, which is 3 into 10 to the power 8 meter per second by 2 into 10 to the power 8 meter per second. So if we solve it, it will come 3 by 2, which is 1.5. So one thing we can note it down, refractive index is unitless. Means as you see here, both meter per second will cancel out. So there will be no unit for refractive index. Second thing, we can note it down. If refractive index is greater than 1, then the medium is a denser medium. And if the refractive index is less than 1, then it is a rarer medium. And if refractive index equal to 1, then same medium. So here if I take example, refractive index of diamond with respect to vacuum is 2.4. It means that here diamond is a denser medium and vacuum is a rarer medium. Why? Because n is greater than 1. Second formula is n21 is equal to n2 by n1. Here n1 and n2 is a absolute refractive index. We know that n21 is a refractive index of medium 2 with respect to 1. But what is absolute refractive index? So absolute refractive index is defined as the refractive index of a medium with respect to the vacuum. It means that here one of the medium is always vacuum. Other medium could be anything, glass, water, diamond, anything we can take. But one of the medium is fixed, that is vacuum. So the value of that refractive index is considered it as a absolute refractive index. So this absolute refractive index can change when temperature will change. So absolute refractive index depends upon the temperature. When we change the temperature, then that value could also change. If I write n glass, no other medium, it means that it is equal to refractive index of a glass with respect to vacuum. So this vacuum we will not use again and again, because if we use a term absolute refractive index, so it's understood that the other medium must be vacuum. Here if I say refractive index of glass with respect to water, it can be equal to absolute refractive index of glass divided by absolute refractive index of water. So right now we saw three formulas through which we can solve the questions based on refractive index. First formula was a Snell's law. Law of refraction. First law of refraction is also called as a Snell's law, which is equal to sine I by sine R, which is equal to n21. Second formula was based on speed of light, which is n21 is equal to v1 by v2. And third formula we just discussed, n21 is equal to n2 by n1. So which formula we have to apply, it depends upon question. If the speed of light is mentioned, then we use the second formula. If absolute refractive is mentioned, then we use the third formula. If angle I and angle R is given, then we use the first formula, which is a Snell's law. Now we will solve few questions based on refractive index, so your concept will be clear. So in this first question, it says that the absolute refractive index of two media A and B are 2 and 1.5 respectively, If the speed of light in medium B is 2 into 10 to the power 8 meter per second, calculate the speed of light in vacuum and medium A. So first we write the given values. Absolute refractive index for the medium A is 2 and absolute refractive index for medium B is 1.5. Speed of light for medium B is 2 into 10 to the power 8 meter per second. And we need to find speed of light for medium A and speed of light in vacuum. So we can use the formula which says that N12 is equal to V2 by V1, or reverse we can also say N21 is equal to V1 by V2. So if we substitute the value of NB and VB, so we can write it as refractive index of medium B is equal to speed of light in vacuum divided by speed of light in medium B. By substituting the values, 1.5 is equal to V by 3 into, sorry, by 2 into 10 to the power 8 meter per second. So after solving, V will come as 3 into 10 to the power 8 meter per second, which is the speed of light in vacuum. Similarly, if we have to find speed of light in medium A, we can write NA is equal to speed of light in vacuum divided by VA, and we substitute the value. 2 is equal to 3 into 10 to the power 8 by VA. The speed of light in vacuum we just calculated from here. Now after that, if we substitute VA is equal to 3 by 2 into 10 to the power 8 meter per second, which is equal to 1.5 into 10 to the power 8 meter per second. This is the answer for the first question. In this question, if the angle of incidence for a light ray in air be 45 degree and the angle of refraction in glass be 30 degree, find the refractive index of glass with respect to air. So first we write the values. According to the question, angle I is given as 45 degree. Angle R is given as 30 degree. So this incident ray is present in the medium air and the refracted ray is present in the medium glass. It means that it will bend towards the normal, because we know that air is a rarer medium and glass is a denser medium. So bending will towards the normal. So in this case, always remember angle I will be greater than angle R. Sometimes MCQ questions comes based on the figure and we need to identify the correct figure. So it will help us to get the correct answer. Now come to the question. We need to find the refractive index of glass with respect to air. So we can use the Snell's law. We can write sin I by sin R is equal to refractive index of glass with respect to air. We can substitute the value. Sin 45 by sin 30 is equal to refractive index of glass with respect to air. So we know that sin 45 is 1 by root 2 and sin R is 1 by 2. So it will come as 2 by root 2, which is equal to root 2. So this is the value of refractive index of glass with respect to air. It can be also equal to 1.414. So this is the answer for the second question. Let's move to the third question. So here in this question, it is mentioned that the refractive index of medium X with respect to Y is 2 by 3 and the refractive index of medium Y with respect to medium Z is 4 by 3. Find the refractive index of the medium Z with respect to medium X. So first we write the given values. Refractive index of XY is equal to 2 by 3. Refractive index of YZ is equal to 4 by 3. And we need to find the refractive index of ZX. So here one relation we are going to use, which is refractive index of medium 2 with respect to 1 is reciprocal to the refractive index of N1 2. So it means that refractive index for medium X with respect to Y is 2 by 3. So we can say that N Yx will be equal to 3 by 2. Similarly, N Zy is equal to 3 by 4. So now here N Zx can be written as absolute refractive index of medium Z by absolute refractive index of medium X. So it can be written as refractive index of Z divided by absolute refractive index of Y into absolute refractive index of Y by absolute refractive index of X. This will not change any equation. So here NZY can be written as ZY into NYZ. And in the beginning, NZY is 3 by 4 and NYZ is equal to 3 by 2. We can substitute the value 3 by 4 into 3 by 2, which is equal to 9 by 8. So this is the answer for the refractive index of NZX, which is 9 by 8. I hope you understood this question. So that's it from this video. In the next video, we will study about the refraction of light in the spherical lenses. Thank you.